Hello everyone, let's continue discussion on searching algorithms. In the last video we have learned about linear search algorithm, right? In this video I would like to explain about binary search algorithm. Before going to see about binary search algorithm, let me once again rewind about linear search. Searching is a process of finding a particular element from the number of elements in the list. To do this process, we are having two searching methods. One is linear search, another one is binary search. In the linear search technique, we compare the elements of the array one by one in sequential manner with search element which we are looking for. So the comparison will take place in sequential order. That's the reason why the linear search algorithm is also known as sequential algorithm. If the element is found in the array, then the search is successful and it will return the index position of the element. If element is not present in the array, then that is unsuccessful, then the process will return -1 as the result. As it is a very simple searching algorithm, but it takes a lot of time, so for that reason we are going for the next searching algorithm, that is binary search. The binary search is one of the fastest searching algorithm, and it works on principle called divide and conquer technique. And binary search algorithm can be applied only on sorted array. Sorted array is nothing but the ordered array either in ascending order or in descending order. All the elements should be in any of the ordered, that is either in ascending order or in descending order. That array is known as sorted array. So in the linear array, so there is no matter whether the elements are in sorted or unsorted. So we can use that linear search at any type of the array. Whereas the binary search can be applied only on the sorted arrays. If the array is in unsorted, then we should use some sorting techniques like insertion, bubble, selection, merge sort or quick sort. Then only we need to apply the binary search algorithm upon those elements to search for the element into the list. So binary search algorithm searches an element by comparing it with the middlemost element of the array. Okay, in the binary search, the searching of the element is done by comparing with the middlemost element of the array. So then the following three cases are possible. The first case is if the element being searched is found to be middlemost element, then its index is returned. That means if the searching element is double equal to middle element, then it will return the middle element as the result. Otherwise, we need to go for the second case. If the element being searched is found to be smaller than the middlemost element, then its search is further continued in left sublist of the middlemost element. That means if the searching element is less than the middle element, then we need to do the binary search to the left sublist of the middlemost element. Otherwise, we need to go for the case 3. If element being searched is found to be greater than the middlemost element, then its search is further continued in the right sublist of the array. That means if the key greater than array of middle, then we should do the binary search to the right sub array of the middlemost elements. By considering these three cases, we can apply binary search technique upon the number of given elements to search for the element. So let's see these techniques by using an example. we are given the following sorted linear order. We need to search for the element 12. We need to search for the element 12. To proceed for the comparison, first we need to find out the middle element. Okay, first we need to find out the middle element. To find the middle, we are having the equation that is middle equal to low plus high by 2. Middle equal to low plus high by 2, where low is nothing but the 0th position, 0th index position. This is the lowest, and high is nothing but the last index position. The n minus 1 position is nothing but the high. Okay, so mid equal to low plus high by 2. So first we need to find out that. So mid equal to low plus high by 2, where low equal to 0, high equal to 8. So 0 plus 8 by 2, that equal to 4. So here the middle equal to 4th index position element, that is 50. So here 50 is the middle element. So we are having the case number 1, that is if searching element is equal to the middle element, we should return the middle element as the output. Is that satisfying? No. So when we are comparing the search element 12 with the middle element 50, is both are matched? No. So what is the relation between these? The search element is less than the middle element. So we need to search only in the left sublist. Okay, are you following? As we have already discussed about the 3 cases, so it is matching with the case number 2, that is the search element is less than the middle element, that is 12 less than 50. So what we need to do? We need to do the binary search only in the left sublist. In the next comparison, to compare the 12 with the middle element, we need to find out the mid. We are having the equation low plus high by 2. Here the low is 0 and high is 3, right? So 0 plus 3 by 2, then we can have the middle, that is 1. 1 is the middle. So the index positioned element of 1 is 12. So now compare the 12 with middle element 12. So we are having the case number 1, that is if searching element is equal to the middle element, then it will return the location of the element, right? So both are matching. So the result is element found at index 1. So let's see the another example. So here are the given elements in the array. So we need to find the element 80. We need to search for the element 80. So binary search algorithm works in the following steps. So to begin with, we need to take low equal to 0, high equal to n minus 1. So low equal to 0, high equal to 8, right? So then we can find the middle. So to find the middle, we know that low plus high by 2, that equal to 0 plus 8 by 2, that equal to 4. So mid equal to 4. So in the 4th index position value, we are having the element as 50. So we are having the 3 cases. Apply those 3 cases upon this. So then we can clearly know that what is the relation between that. So is such element is equal to the middle element? No. Is such element is less than the middle element? Is 80 less than 50? No. So go for the case 3. Is such element greater than the middle element? Is 80 greater than 50? Yes. So the case 3 is satisfying here. So if the such element is greater than the middle element, so what we need to do? We need to do the binary search only in the right sub list, right? So in the next comparison, in the second step, we need to compare the middle element. To find out the middle element, we are having low plus high by 2, that equal to 5 plus 8 by 2. The middle equal to 6th positioned element 65. Now apply the 3 cases here. In the case 1, is middle element is equal to the searching element? No. The case 2 is in the case 1, Is the search element is equal to the middle element? No. So go for the second case. Is search element is less than the middle element? No. So take the case 3. Is search element is greater than the middle element? Yes. 80 greater than 65. So what we need to do? Do the binary search in the right sublist only. So it will go for the next iteration. In the next iteration, step number 3, again we need to find the mid. So to find the mid, we need to take low plus high by 2. So that is 7 plus 8 by 2, that equal to 7. So here mid equal to 80, right? So we need to compare search element with the middle element, that is 80 with the 80. So apply the 3 cases here. Is 80 double equal to 80? Yes. That's so it will return the middle element only. So as we are having the first case, if the search element is double equal to the middle element, it should return the middle element as the result. Okay, the index position of the middle element as the result. So both are matching here. So the result is element found at index 7. So this is how we need to apply the binary search technique. So upon the number of given elements to search for the particular element. And now we will see the binary search algorithm. As the algorithm is having A as array with n number of elements and also with searching item. Here item is nothing but the key element which we are looking for. If the element is present in the array, it will return the location of that particular element. Otherwise, it is unsuccessful, then it will return -1 as the output. Here we are having the binary search with A, n item. So A is array name, n is number of elements, and item is nothing but the search element. So begin the algorithm. So before going to begin the algorithm, we need to take low equal to 0, high equal to n minus 1. Okay, because so it should repeat the process from 0th position to the last indexed position value. Okay, now we are taking the loop, that is low less than or equal to high. Then find the mid. To find the mid, we are having the equation low plus high by 2. After that, we need to consider the 3 possible cases. One is if the mid element double equal to searching element, then return the mid. Otherwise, the second condition, if the searching element is less than the middle element, we need to take high equal to mid minus 1. If both are false, then take the third case, that is less than case. If item is less than the middle element, we need to set high equal to mid plus 1. If all the cases are going to fail, so then we need to end if statement as well as if condition as well as while loop. Then that means that the search is unsuccessful, so we should return -1. That represents key is not found in the list of elements. So this is the binary search algorithm. So let's see the complexity of the algorithm. So it is having the best case time complexity as order of 1. So and the worst case complexity as order of log n. And it is having advantages and disadvantages. First we will see the advantages. If it eliminates half of the list from further searching by using the result of each comparison. So it indicates whether the element being searched is before or after the current position in the list. So this information is used to narrow the search, right? So that is the first advantage. And for large list of data, it works significantly better than the linear search. So these are the advantages of this binary search. And coming to the disadvantages, programming binary search algorithm is error prone and difficult. Okay, and the interaction of binary search with the memory hierarchy, that is the caching is poor. So why? Because it is accessing the elements randomly. So for that reason, so it is very poor to access the memory hierarchy. So these are the advantages and disadvantages of binary search algorithm. So I hope you all understand about these searching algorithms, linear search algorithm as well as binary search algorithm. Thank you.